electric dipole placed in uniform electric field. Let us consider a uniform electric field capital E represented by the parallel field lines which are equidistant and pointing towards the same direction. A dipole of charge Q and length 2a is placed obliquely in this uniform electric field. We know plus Q charge experiences a force in this direction, in the direction of electric field, and minus Q charge experiences a force opposite to the direction of electric field. Force experienced by plus Q charge is F equal to plus QE, and force experienced by minus Q charge is minus QE. Now this is plus QE and this is minus QE. This is just a symbolic representation of the situation what we had explained. An electric field E is pointing in this direction, represented by this vector. This is the dipole which is experiencing plus QE force in this direction, minus QE force in the opposite direction. And these two forces are equal, but they are opposite to each other. Since their lines of actions are not coinciding, they must constitute a torque on this dipole. This dipole moment always acts from minus Q to plus Q. The dipole moment is making an angle theta with electric field capital E. Let me represent the dipole moment in this direction. This is the direction in which dipole moment acts. That is P. This is the direction of electric field. Between P and E, angle is theta. Let us calculate what is the net force experienced by this dipole in the electric field. We know net force experienced is plus QE plus minus QE. So here you can see it is plus QE plus minus QE, which is equal to 0. So net force experienced by the dipole in an electric field which is uniform is equal to 0. Plus QE plus minus QE equal to 0. Now what is the torque experienced by it? Since these two lines of action are different, these two forces are anti-parallel, definitely these two forces should constitute a torque on this dipole. And we know torque is one of the force into perpendicular distance. What is the perpendicular distance here? These are the two forces. Hence, between them the perpendicular distance is Bn. What is Bn? If we construct a triangle ABN, sin theta equal to Bn divided by 2a, or Bn equal to 2a sin theta. It is represented here, sin theta equal to Bn divided by 2a, or Bn equal to 2a sin theta. Substituting the value of Bn in the equation number 1 for torque, tau equal to F, already we know one of the forces QE, magnitude is QE. So QE into perpendicular distance is Bn. That already we had calculated. Tau equal to QE into 2a sin theta. Combining this we can write 2aq into E sin theta, and we know 2aq is P or this is equal to PE sine theta. Tau is a vector quantity, hence it can be written as a vector product between dipole moment and electric field. Hence tau equal to P cross E. Very important equation. Now let us see the different cases. When theta equal to 0. Theta equal to 0 means when the dipole moment is parallel to electric field. This is dipole moment, and if I represent electric field also in the same direction, then the angle between dipole moment and electric field is 0. So no torque is experienced by the dipole. That means it is in stable equilibrium. Now let us see when theta equal to 90 degree. When theta equal to 90 degree, this is the case when theta equal to 0. When theta equal to 90 degree, then we can see the electric field is acting in this direction. Electric field is acting in this direction, and dipole moment P is acting perpendicular. This is the direction in which dipole moment P acts, and this is electric field. Between them angle is 90 degree. In such case, we can write tau equal to PE sine 90, which is 1, that is equal to PE. Tau equal to PE. Now the third situation you see, that is when the angle theta is 180 degree. Here we represent the electric field in the same direction. Let me represent. This is the electric field E, and dipole moment must be opposite. Then only angle is equal to 180 degree. So let me represent the dipole moment P. The dipole moment is acting in the opposite direction. So here P is anti-parallel to E. In such case, tau equal to PE sine 180, which is equal to 0. Thank you.